So this is AP Physics 1, Unit 1, the most misconceptions. So if you look at here, there are three graphs. The first graph is a DT graph, then a VT graph, then an AT graph. And so the DT graph stands for the displacement graph. The VT is velocity, and AT is acceleration graph. Now, if you want to figure out, if you were given a DT graph and you want to find a VT graph and an AT graph, some of the times it could be confusing to you. But there's a very simple explanation for all of this, and it is to use derivative. Now, if you have taken calc or is taking calc, this is very easy to understand. So if you look at the first graph here, the DT graph, we could call it x squared. And to find the derivative, the formula for derivative, the power rule, is x to the nth term minus 1 times n. Now, n in x squared is 2. So if you have x squared minus 1, so that is equal to x to the first power times n, and the nth term is 2, so it'll be 2x. And to find so that's your equation for the velocity graph. As you can see, that's a linear graph. Now, to find the derivative of 2x, it will be, so 2x to the first power minus 1 is equal to x to the 0th term. And anything to the 0th term is equal to 1. So that's just 2. So your acceleration graph equation will be just 2. And you can see it's a constant, it's a zero acceleration. And if you want to go backwards, let's say you're given a acceleration graph and you want to go to velocity, well, that just going backwards. And what you would do is you would use the integral. And for integral, the formula is x to the nth term plus 1 over n plus 1. So let's say it's 2x to 0 plus 1 over 1. So you can see it is equal to 2x to the first power, which is equal to 2x. Now from 2x to x squared, that'll be the same thing. It'll be 2x plus, so x1 plus 1, so that's x squared, and it'll be 2x squared over 2, because it's 1 plus 1 is equal to 2. So now these two cancel and you get x squared. But yeah, that's pretty much how you solve for it. And this makes sense because if you think about it, in a VT graph, it's linear. So if it's linear, there is no acceleration. So your acceleration would be just constant. It will be 0. Now let's go to the displacement versus distance. This is another very misconception in Unit 1. So for displacement, it is the movement from the origin. Let's say this point is your origin, and the area under these two curves are your distance, right? Or displacement. So displacement, you have to keep in account of the sign. So for this area under the curve, since it's above the x-axis, it will be positive. And for this area under the curve, it will be negative. So let's say the positive area under the curve is 8, and the area under the curve is 2. So your displacement will be 8 minus 2, which is equal to 6. That's your displacement. Now, it's positive 6, and you always have to add the sign because displacement is a vector, and you have to show your direction. Now, for the distance, it's the total distance moved. So you actually don't have to take in account of positive or negative, since both of these will be positive. And so it will be 8 plus 2, which is equal to 10. Because that is the total distance moved from this point origin. Now, if I were to give you a question, so a runner starts on a circular track and he starts on this point here and he runs around the whole circle or just around the whole track and he ends up in the same place. What is your displacement? Well, displacement is equal to 0. And that is because you actually haven't moved from your point in origin at all. But your distance will be the whole track, and that's your distance. Now that is all for the first unit. In the next video, we will look at advanced kinematics.